run a test. There is an observer function written. There is a .c file, where we have written this test condition code. Okay. And it will be run in certain time duration to check whether all the features, functionality, everything is working fine or not. Understood? So if the test detects there is an failure, okay, then it will store that failure in the form of DTC number. Okay, so see, if we'll talk about fault is nothing but some kind of failure, right? In our ECU, correct now? Yes or no? Some kind of failure is there in our ECU, right? So if I'll say in general, there can be in complex ECU 400 to 600 different types of fault are checked. Okay. So if I'll talk about complex issue, let's say I'll talk about braking system, engine control module, transmission control, or power steering. These are critical issues, right? And complex issues. Their functionality is complex. So even some of the issues, it can go more than 1,000 and 1,500 faults also. Okay. I'm talking in general, if there is a complex issue, there can be 400 to 600, 700 faults, different type of faults implemented. So different types of fault means there are different conditions we have written. Okay. Let's say we'll take example. Okay. Our ECU, okay, detected voltage is below, let's say 9 volt. Okay. Or voltage is above 16 volt. Okay. Then what will happen? Then ECU will detect high voltage fault. Okay. For above 16 volt, and ECU will detect low voltage fault. Understood? When the voltage is below 9 volt. So how this fault detection is happening? We have a fault condition. Okay. So in the code we'll write, let's say if voltage is less than 9 volt. Okay. Then set DTC for low voltage fault. Understood? Guys? Hello? Is it understandable what I'm telling you? Guys, in embedded C, we are writing code. Correct, now? Yes or no? So how you'll write? You'll check for different logics, right? So let's say in the microcontroller, we are reading what voltage this microcontroller is receiving from external source, power supply. And in the code, we will check if the voltage received is less than 9 volt, then detect as a low voltage fault. Understood? So this monitor function or observer function will run every 100 millisecond. This function is called, it will check, is the voltage correct? No, there is a low voltage detected. The voltage is 8 volt. So then the ECU will trigger a fault, okay, low voltage fault. And when this low voltage fault is triggered, after some time, that is maturity time, that DTC related to low voltage will be stored in the memory. Guys, understood? Yes or no? Guys, did you understood fault? What do you mean by fault? Guys, please speak up. Not understood, right? At least tell me. Understood, not understood? Huh? So, what about others? What?
Yes, sir, understood.
Understood, right? So we have written code that will check for different scenario. So this is just two example I have given. Okay, maybe uh, let's say one more fault. Our ECU, okay, is not able to receive vehicle speed message, which is coming from other node. Okay, so if the ECU does not receive, for that we'll raise ECU will detect as a timeout. Okay, and fault vehicle speed, okay, message absent, fault will be triggered. Understood, guys? So our ECU is checking whatever the message we are supposed to receive. All these messages are coming or not coming, or coming. If the messages are not valid, then there also can be fault. Guys, are you understanding what is this fault? Guys, are you able to understand this?
Yes, sir.
What about others? What about others?
Yes, sir.
Understood. So like this, there can be 400 to 600 different types of fault. Okay, implemented in an ECU. There are different if else statement in which will validate whether the fault is there or not there. Understood? Now, how the fault will be detected? When the fault will be triggered? When there is fault condition detected. right? Correct now? How this low voltage fault will be triggered? If the ECU received voltage from the power supply is less than 9 volt. So this less than 9 volt is the fault condition, right? When this fault condition is satisfied, then only this fault will be detected. Correct now? And similar for this, if the voltage is greater than 16 volt, that will leads to high voltage fault detected. So the condition, fault condition is if the power supply is giving more than 16 volt and ECU is receiving more than 16 volt from the power supply, then the ECU will detect as a high voltage fault. Understood? So for each fault, there will be a fault condition. Okay? Understood? And there will be fault maturity time and fault recovery condition. So you need to understand these three terms very carefully. Okay? Understood? Guys, are you getting my point? You need to understood this fault condition. Okay. So I will explain you in, let's say, graphical. Okay. Now we have a voltage. Okay. Okay. And we have fault raise. Okay. Now, let's say our voltage is coming constantly 12 volt. So this fault condition will be false. Okay. Understood? Now let's say this voltage now increased to 17 volt here. Okay. Now the voltage detected by our ECU is 17 volt. So this high voltage fault is there, right? This will set to true when the voltage is detected 17 volt and it will remain true. Understood? Can you see here? This is the point where fault will be detected. When the ECU detect the voltage is above 16 volt, then immediately that ECU will set a variable which is high voltage fault set to true. Okay, understood? So this is the fault condition. Guys, have you understood here? Guys, have you understood? Now we have this fault is true. That doesn't mean DTC for this fault. Okay. Now, before starting DTC, I'll tell you a few things. Okay. We have fault. Okay. Once the fault is there, then this fault will be mapped to some DTC number. Okay. And this DTC number is of 3 byte. Okay. 3 byte, let's say 01, 02, 03. Okay. This DTC number is of 3 byte. So when a fault, every fault, not every fault, let's say we have 400 to 600 faults, right, in our ECU. Not every fault will be mapped with DTC number. Some fault doesn't require to be stored. Like I told right earlier, there are some critical fault, there are some non-critical fault, there are some okay faults. Okay fault means if that fault is there, still your ECU will work. Critical fault if that fault is there, your ECU will not work. Understood? It will work in fail-safe mechanism. Guys, are you getting my point here? Guys? Okay. So let's say we have one high voltage fault. Okay. And for high voltage fall, one DTC 02, 01, 02, 03 is mapped. Okay. And for this low voltage fault, another DTC. Okay. Let's say 04, 05, 06 is mapped. So when this fault is detected, this is high voltage fault, right? Then this DTC number will be stored in the memory, but immediately it will not store. When this fault is set to true, immediately DTC will not be stored in memory. It required fault maturity time. The ECU needs some time to confirm whether the fault has actually raised or not raised. Sometime happens, right? There is a fluctuation in voltage just for 10 milliseconds. Okay. Voltage went to 17 volt and then again came down to 12 volt. Sometime happens, right? Voltage fluctuation. होता है ना? Guys, are you getting my point? Sometimes it happens, right? A voltage surge is there just for 10-20 milliseconds. After that, that voltage came to normal. Is it required to store that fault in the memory? Because that happens just for some milliseconds, and then that fault is not there. So is it required to store that fault in the memory to occupy the memory? Is it required? Guys, not required, right? Yes, na? Yeah, because that fault happened, but that happened for very little time. And now it is not creating any problem in the ECU. It happened one time just for very little. There was a surge due to some reason. So that's why there should be a fault maturity time. Okay. So what is fault maturity time? So here DTC is not stored. So when the fault is detected by ECU, and let's say it takes 500 millisecond more to validate that fault. Okay. This from here to here distance is 500 millisecond. Okay. From here to here. Understood? When the ECU detected the fault condition, then it will wait another 500 millisecond. This fault is constantly true for 500 millisecond. Then store that DTC information in the memory. If let's say what happened is this happened only for 100 millisecond, and then again this voltage come back to 12 volt here. So what will happen? This fault will happen for 100 millisecond. Again, this fault will set back to false before this fault is matured. Then in the DTC, ECU will not store this history of this fault. History of this fault will not be stored in the memory. Got my point? Guys? Have you understood, not understood? See, the fault condition is detected. Immediately the fault condition is detected, fault will be set to true. Okay. But the fault should be set to true for some time duration to confirm whether this fault is definitely there. Okay. And this time depends on each fault. If there is some critical fault, it can be this time can be 0 millisecond also. Immediately this fault is logged, immediately that will be stored in DTC. Some fault, it can be 100 millisecond, it can be 500 millisecond, it can be 1000 millisecond. That depends on the OEM, how much maturity time they are configuring for that particular fault. Guys, understood what is this fault maturity time? The maturity time is here. When the fault is detected and when the fault is confirmed, this time is fault maturity time. Guys, understood? Okay. So sometimes it happens, just fault has raised only for some millisecond. Okay. So then in that case, it is not required or not necessary to store this DTC information in the memory. Not required. Unnecessary. Why will consume memory? We have limited memory, right? Right now. Okay. So that's why there will be a fault maturity time implemented that depends on fault to fault. Every fault can have separate maturity time. Some can be having 0 millisecond maturity time. Immediately fault is detected, it will be stored in the memory. Some fault may have 500 milliseconds, some fault may have 100 milliseconds, some fault may have 50 milliseconds. Understood? So that is maturity time of the fault. When a fault condition is detected, and if that fault condition stay for maturity time, then only that information will be stored in the DTC. And this maturity time can be 0 millisecond, it can be 1000 millisecond also. That depends on fault to fault. Understood? My writing is very poor now. Understood, guys? Okay. So now what is this fault recovery condition? So now a fault condition is detected and it stays for maturity time, then the DTC information will be stored. Okay. When the fault is condition is detected and after some time, somehow this fault is recovered. Okay. Now here it recovered. So then this fault flag is there, right? This will also recover to false, but not the DTC. This will be always true. Once the fault is matured, okay, this information will be there in the memory. Okay. Let's say after, let's say 1 hour, automatically this voltage, high voltage was coming, somehow it got rectified. And this power supply is again giving 12 volt. ECU is detecting 12 volt from the power supply. Then the ECU will pass the test case, what is was running. Test case was there, na? If condition. If voltage is, sorry, greater than 16 volt. Correct? Else, now it will go to else because now again the voltage has come down. So in else, reset the fault. So now this fault will set to false because now the voltage is not greater than 16 volt. So then this statement will be not executed. It will go to else. In else, we have written set the high voltage fault back to false. But whatever the DTC which is stored in the memory, this will not be removed. Okay. Understood, guys? Guys, understood? But one thing happened when the DTC is stored, okay? DTC will be stored with some other parameters. That is DTC status byte information. Okay. DTC snapshot record information. and DTC, extended data information. When a DTC is stored in the memory, along with the DTC, status of the information, snapshot record of the information, extended data information will be stored in the memory. Okay. This status byte tells what is the current status of this DTC. Now for here, DTC is now pass. That means this DTC was there, but it was there in history. Now this fault is not active. Understood? That I will go in detail. Don't worry. This point, have you understood, guys? Guys, you understood how the faults will be detected? What is the fault condition? What is the fault maturity time? What is the fault recovery condition? This have you understood, everyone?
Yes, sir.
Okay. So although I told there can be 400 to 600 faults, but there will be maximum 25 to 30 or 40 DTCs only, which we can store in the memory. Okay. Not like you have 400, 600 fault and you can store some kind of, let's say, 400, 600 DTC. It's not the case. Okay. With one DTC, similar kind of faults will be attached. Okay. So I'll give you example how. Okay. Now let's say we have torque sensor. Okay. We doesn't have one torque sensor. There are 3 channels of torque sensors in the ECU. Okay. Now channel 1, channel 2, channel 3. Now, if there is any fault related to torque sensor, let's say a DTC is 0A, 28, okay, 0A, 28, and 01. This is 3 byte of DTC, which is linked with sensor torque sensor related fault. So if there is fault observed in channel 1 or 2 or 3, this DTC only will be stored. Understood? So this separate 3 faults leads to only one DTC stored. If any of these faults are there, then this DTC, if any of these faults set to true, then DTC this will be stored in the memory. Understood how it's working? Different faults will be mapped to a separate one single DTC. And those different faults are should be similar. It's not like one is torque sensor fault and another is angle sensor fault. Both are linking to one DTC. It's not good. If there is fault related to torque sensor, then a DTC this will be stored. Okay. Understood? Guys? Guys, understood?
Yes, sir.
What about others?
Yes, sir.
Are you able to understood or not? Just tell me. Don't say false. Yes, sir. Yes, sir. I just want to know, have you understood this point? Because these points are very important. Guys, understood, na? So let's say this torque sensor channel 1 fault, torque sensor channel 2 fault, torque sensor channel 3 fault. If torque sensor failure detected, then torque sensor channel 1 fault will set to true here. And if this fault stay for maturity time, then this DTC will be raised, or this DTC will be stored in the memory. Got it? So likewise, for 400 to 600 fault, there won't be 400 to 600 DTCs. Some common faults will be linked with a single DTC. Okay, so hardly in, if you'll see in our project, so 20, 30, 40, that's it. Some complex issue, you may have some 80 or 100 faults, like engine control module or our braking system. These are very complex issues. So maybe in these issues, you can see 80 or 100 ETC. But if we'll talk about power steering, we'll have 25 to 30 ETCs. If we'll talk about other less complicated issue, you may have some 10, 15 DTCs only. Understood? Okay. So this one is clear na, till now. If any fault condition is detected, yeah. And if that fault condition is detected, then a fault will be set to true. And if it is matured, then only that DTC will be triggered and it will be stored in the memory. Okay. And DTC will be of 3 byte information. Okay. I told now DTC status byte, correct? Then we'll have a snapshot record, and then we'll have extended data record. So once the DTC is stored, so DTC will be of 3 byte. Along with this DTC, we'll have additional information. Okay, and that additional information is DTC status byte, which will tell what is the status, current status of this DTC. It will talk about snapshot record, okay, that I'll discuss later. And we'll talk about extended data record, that also I'll take later. Understood? Guys? Guys, understood?
Yes, sir.
Understood now? What about others?
Yes, sir.
Okay. So now we'll talk about what all kinds of different kinds of faults there. Okay. So we'll take, there are different 400 to 600 faults, but we'll see some common 510 faults. Okay. Understood? Understood? Now we'll see what are those faults. So there are CAN related faults. Okay. Now, this CAN related faults, do you remember when I was teaching CAN? Like I told, in the application layer, our code also validate whether the message received, is it correct or not? Do you remember Anyone? I told, see, can itself is validating. Checksum, acknowledgement, other errors are there, right? Guys? But apart from that, I also told in the application layer, we are validating some different false conditions also to just double check whether whatever the message we have received, we received it properly. Do you remember, guys? Guys, but not remember. Not remember, right? Tell, not a problem. If you don't remember, I'll tell it again.
Okay, sir.
Not remembered, right?
Yes, sir.
So tell, not a problem here. I told na, you might forget. See, first time it's very difficult to memorize everything. Okay. So it's okay. You can tell, but tell at least. Okay. So one type of fault will be timeout fault. Timeout or message absent fault. Okay. Another fault is in the application, we have implemented CRC check. Okay. That I'll tell you how it is being done. There is another type of fault is CRC fault, which is validated at the transmitter and receiver. Guys, are you getting me? Don't get confused this CRC with the CAN CRC. We have one CAN CRC field also, right? Guys, don't confuse this with the CAN CRC fault. We have CAN in the CAN CRC field also, right? This CRC is validated. Okay, I will, I will go in detail, don't worry. Okay. Another fault is rolling counter fault, or we can say it hello. Guys, can you able to hear me?
Yes, sir.
Hello. Guys, am I audible?
Yes, sir.
Hello,
Sir,
am I audible?
yes, sir. Audible, sir.
No response. I thought I got disconnected. Some technical issue is there. Tell something, yeah. I was keep on asking, am I audible? Am I audible? Nobody responded. So is my screen visible, right? 20 screen?
Yes, sir.
Okay. So the next kind of fault is rolling counter. Okay. Or counter fault. The last one is invalid fault. Some project you may even find DLC fault also related to message. Okay. So these 4 to 5 types of fault will be there for CAN related. Let's say, take an example of, we have one SAS message, okay, that is steering angle sensor. Okay, so this steering angle sensor message will be given by a angle sensor which is fitted in the steering portion. Okay, this will transmit the steering angle sensor value to all other ECU. What is the steering position, or what is the position of the steering driver has requested? Let's say driver want to turn the steering to 30-degree anti-clockwise. Then that information sensor will give through CAN message to all the other nodes. Okay. So now we'll take an example of SAS message. Okay. Now let's say our ECU is receiving this message. Okay. Our ECU is receiving this message. So this message can be received, okay, by our ECU and will validate, is this message received is correct or not. How it will do? First validation, it will look for timeout. So timeout means if the node which is responsible for sending this message is not sending within a specified time. Let's say the message is transmitted every 20 milliseconds periodically, and the node which is supposed to transmit this message is not transmitted for 100 milliseconds. That means 5 messages are missing. Okay. So when this message is not received by our ECU for some maturity time, then it will detect as a timeout or absent fault. Understood? If a message which is supposed to receive by our ECU within some time duration, that is maturity time, but it has not received, then the ECU will detect timeout or absent fault that message. Okay. Then in that case, what will happen? The ECU will trigger SAS message absent fault. Understood, guys? Have you understood? Guys? Guys, understood or not understood? What about others?
Understood, sir.
Sleeping, huh? After
Understood,
lunch?
sir.
Is it also sleeping? After lunch is difficult, right? This is sleeping time, right? Okay. Understood now? What is this message absent fault? Okay. Now we'll talk about CRC. So when there is a CRC signal, hello, audible, right?
Audible, sir.
Guys, am I audible?
Yes, sir.
Guys, am I audible?
Yes, sir. Audible, sir.
Okay. See, the second fault is CRC fault. Okay. So in a message, there are different signals. Okay. So just a minute. I will show you or else the DBC file. I'll give an example of CRC and rolling counter. Then I'll tell how it works. Okay, now is DBC file visible? Okay. So is this message? We have EPS message. Okay. In this EPS message, we have three different signals. One is CRC, clock, EPS warning. These two signals I am talking about rolling counter or clock and CRC. Okay. So what it is done is this CRC will be calculated by our application layer. Okay. Based on other bytes. Okay. Take example, this CRC equal to maybe byte 1 plus byte 2 plus byte 3 and XOR with FF. Whatever the value will come, that will be the CRC. And that will be stored in this signal and transmitter will transmit. Once the receiver will receive it, at the receiver end, it will again calculate with the same algorithm this CRC value. It has received all the 4 bytes. So with the same algorithm, it will calculate byte 1 plus byte 2 plus byte 3 XOR with FF. Whatever the value came, is it same what it received in the CRC signal? If both are coming correct, then it will detect there is no CRC error, or else it will detect a CRC error. So this is not done in the CAN part. Okay, this is done in the application layer because this is part of data field. Understood, guys? This is part of data field, not CRC field. CRC field, whatever the value is there, that already will be taken care by the CAN trans receiver. But this is additional CRC we are checking to validate whatever the message in that message, whatever the signals we have received, everything is fine. If you'll see other messages also, maybe let's say this. Do we have CRC here? No, I think for this message there is no CRC. Maybe some other. Check. No. So this CRC and rolling counter will not be there for all the issues. Only for critical issues whose information is very critical, then only this CRC will be implemented. Okay, not for every message. This also CRC. Yeah, here we have. For this message also you can see CRC and clock. Guys, can you able to see?
Yes, sir.
So for some of the messages which are critical messages, this CRC and ruling counter or clock will be implemented. Okay, not for all the messages. All the messages will have signal. In that different signal, this CRC and clock signals also will be there. Understood? So what will happen is transmitter will calculate CRC and with the message one signal CRC signal it will send calculated CRC value. Understood? Transmitter will calculate the CRC and with one of the signal the CRC value will be sent. Receiver will receive it, then receiver will again revalidate whether the CRC is correct or not. If CRC is not correct, then CRC fault will be detected at our ECU. Okay, and that fault can be, let's say, SAS, message, CRC fault, or checksum fault also they can say. Checksum fault. Understood? So if the CRC validated in the application layer is not correct, then message, SAS message, checksum fault will be triggered. Got it? Guys?
Yes, sir.
Okay. Now we'll talk about rolling counter, or we can say it is clock fault. So now the third type of fault is rolling counter or clock fault. See, what will happen now? Here we have transmitter. Okay. Transmitter is transmitting. So for first transmission, this transmitter will set clock signal as 0. Okay. And will transmit. Receiver will receive it. Then it will check clock is equal to 0. Fine. Now next time when the transmitter will transmit, then it will set this clock signal to 1. Receiver will receive it. Again, it received clock as 1. Fine. Next time it transmitted to 2. Okay. So like this 0 to 15, the clock signal will increase. Again reset back to 0. Then again 0 to 15. Why it is done? Let's say the transmitter has transmitted clock now equal to 3, then 4, then 5. Okay. But receiver missed this 3 and 4 somehow. Transmitter has transmitted clock set to 3 and 4, but receiver does not receive these two messages. Okay, somehow it lost in the CAN network. Then next time receiver received, it checked clock is now 5. But previously when it received, it was 2. Where is this third and fourth message? Got it? By seeing this clock, receiver and transmitter both will be in sync. Whatever the message being transmitted by transmitter, everything has been received by the receiver. If in between one or two messages are missed out, then the receiver next time once it will receive, the clock will be different. Whatever he is expecting clock should be 3 or 4, it received the clock value is 5. Then it will detect there is a different clock value. Clock is not correct. Understood my point? Guys? Understood this clock? Why this clock is implemented? For synchronization of transmitter and receiver. Whatever the message has been sent by the transmitter, all message has been received by the receiver or not. Guys, is it clear?
Yes, sir.
Everyone, is it clear? Clear now? So if the receiver validated and it detected the clock is not as per the expectation, then receiver will raise fault. SAS clock, SAS message clock fault will be raised by the ECU. Got it? The next is invalid fault. Okay. Now just imagine the SAS signal, that's angle sensor position. That signal SAS is sending, let's say 30° clockwise. Okay. But how we can show the sensor which is there, which is capturing this signal value, is it correct or not? How we can ensure? So there is one invalid signal in the message. If the sensor is not working properly, then in the CAN, it will say invalid. Sensor value is there, but the value is invalid. The invalidity flag will be set to true. Okay. So once the receiver will receive it, it receives 30° clockwise. But the invalidity signal is set to true. That means whatever the data received, it is not correct because sensor is not reading properly. Guys, understood? Guys, have you understood this? Guys? Have you understood?
Yes, sir.
Good. So if the receiver receive it, invalidity flag is set to true, then ECU will detect as an SAS message invalid fault. Message is received, data is also received, but the data is invalid. We cannot say sensor is working fine. Sensor can be faulty. So this flag shows the node who is sending SAS message is sending, but sensor reading we cannot justify. Is it correct or not? Sensor may be not working properly. So just telling that receiver node that whatever the data we are sending, that not be correct. It can be invalid because sensor is not working. Understood? Understood now?
Yes, sir. Yes, sir.
And the last, yeah, and the last one is DLC. So is my database file visible? So for this message, AVM A120 0x3A4, the DLC is defined as 2. Okay. Now somehow when the receiver received this DLC changed to 4, or DLC changed to 3, or DLC changed to 8, other than 2, then the receiver will detect this message is having DLC fault. Understood? Guys, have you understood? Everyone?
Yes, sir.
Okay. Good. So is this point clear about the faults? Have you understood something? At least 20-30%? What about others? So we have seen 2 types of fault. One is CAN related fault. CAN related, we have 5 types of fault. Timeout or absent, CRC fault, we have rolling counter or this what we can say clock fault. We have invalid fault and we have DLC fault. Okay. Now one type of fault we have seen related to voltage. If voltage is high voltage fault, low voltage fault. So imagine for one signal we may have 5 types of fault. Maybe if 20 signal our node is receiving, so only 100 related to CAN fault. Understood? Guys, there can be 100 fault only related to CAN messages. Now we have voltage, sensor related, so many faults are there. It can be 400 to 600 faults. Guys,
Yes, sir.
clear now? Any question? Any question as of now? Good question. Okay, fine. Then if you don't have question, we'll close today. Okay. This is, I think, sufficient. If I'll go more, then it will be overloading for you. Okay, now I'll post it in the group when we'll have our next class. Okay. Because tomorrow, I think from tomorrow you'll have morning session class now. I'll post in the group. Okay.